in a little bit more detail to hopefully help give you a better idea of what you can expect on the next test. So the next test, test 2, will be over chapters 4, 5, and 6. This is the study guide that we have posted. And the first page, just like all my study guides, consists of some terms to be familiar with. You don't have to know word for word formal definitions, but be able to recognize these terms when you see them on the test. I want to go over a few of these specifically to clarify how I expect you to use these. Call that our scatter plot is from chapter 4. That's our way that we analyze bivariate data. Scatter plot will look something like this. And down here on this horizontal axis, you have the explanatory variable. This is your x. And on this vertical axis, you have your response variable, which is your y. And we try to make some predictions sometimes with these bivariate data sets. You use your explanatory, your x, to make a prediction about y. Use your explanatory x to make a prediction about y. Moving down to the next term, the correlation coefficient. Recall that's just r. R is between -1 and +1. Can be strong, moderate, or weak based off of that r. Where the coefficient of determination, that's r squared. And that's the percent of variation in y, your response, that's explained by x. Also in chapter 4, we talked about trend. It's either positive or negative. The strength based off the r can be strong, moderate, or weak. The shape could be linear or nonlinear. Recall that we need to see a linear shape in our scatter plot in order to use r and r squared as our calculations. If there's a clear curve, we don't have the tools to make the calculations in this course. Recall that scatter plots show correlation, that there's a relationship between these two variables, a strong relationship, a moderate relationship, or a weak relationship. But we can't say there's a causation going on, that this x variable is causing a change in the y variable. And then another term that we discussed in chapter 4 was extrapolation. That's when you make a prediction outside of your observed data. So let's say this data on the scatter plot went from 0 to 15 on this x-axis. I couldn't make predictions for 17, 18, or 30, or 40 because they're outside of the observed data range. That would be extrapolation. The regression line had the form y equals a plus bx. The slope is b. The y-intercept is the a. For the slope, its interpretation is how much we predict the response variable will increase or decrease by as the x goes up by 1. The y-intercept is our prediction for the y when x is 0. Slope, x is going up by 1. Y-intercept, x is going up by, x is just 0. Those are the main terms to know from chapter 4. Next up for chapter 5, all about probability. Remember, empirical probability is when you get probabilities from an experiment, when you actually carry out something. You flip a coin, you roll dice, whatever you do. Theoretically, we just use our sample space, the possibilities, that we have. We had OR events, AND events, and given events. Recall that OR means total or add, AND means overlap, / multiply if you have multiple events, and given refers to a conditional probability. Moving to this next column, you'll see some chapter 6 terms. This first term, binomial probability, is something that we did not cover. This will not be on the next test. This was cut for the sake of time. You do need to be familiar with z-score, the normal model, bell-shaped distribution, how the mean and standard deviation apply to that normal model. Finding probability with technology that refers to using normal CDF on your calculator. Finding a measure corresponding to a percentile that refers to inverse norm on your calculator. Various probability problems, those go back to the chapter 5 videos, as does probability from a two-way table and probability notation. In the next few videos, you're going to see some examples of all of these. But just to wrap up the terminology, know the differences between numerical and categorical data. That goes back to chapter 2. That's a review. Discrete and continuous come from chapter 6. Mutually exclusive versus non-mutually exclusive events. Those come from chapter 5. And those apply specifically to OR probability problems. Independent events refer to AND probabilities, as do dependent events. There's only one formula you need for this next test, and it refers to independent events. You need to know that two events, A and B, are independent if the probability of A equals the probability of A given B. So two events, A and B, are independent if the probability of A is equal to the probability of A given B. This is from chapter 5, and you can see a video with several examples testing this formula, and you'll see an example in this study guide in one of the upcoming videos. To close this video, just remember normal CDF has 4 entries. You've got your lower bound, your upper bound, your mean, and your standard deviation. Inverse norm just has your percentile as a decimal, then your mean and your standard deviation. So in the next video, I'll pick up with some examples